In this section, we're going to talk about variables. As a computer program steps through the code that it's going to execute, many different values are computed. The results of those computations are not remembered by the computer unless the programmer explicitly tells the program to remember those values. We remember values by saving them in an area called a variable. It's a piece of memory that has a name. Now, everything in the computer is stored as a number. What that number is has to be interpreted for various data types. Not all variables hold the same type of data. If we want to store the value of pi, which is floating point, that is, it has a decimal portion, would want to choose a double data type. Integers do not save or store a fractional portion. We want to name our variables something that's meaningful to us as programmers. We don't want to choose names that are just simply funny or frivolous, but have no meaning to the program. Once we have an area of memory that is going to remember a number, almost always we want to initialize it to a first value. Since all of the memory in a machine has some pattern of ones and zeros in it, it behooves us to know exactly which pattern of ones and zeros, because when the machine powers up or when it runs and uses memory, and that memory is used by some other program later, there's no telling what might be in there. A variable ought to be initialized. Now, there's a couple different ways of initializing. The primary ones are that a programmer gives the variable a value, such as this. Let's try int count. Let's assume we're going to keep track of a number of things that occur. We would want to start at 0. Whatever is in the memory location count, whatever that bit pattern is, gets overwritten by the pattern for 0, so we know what we're starting with. And then something happens, I'm not going to actually do anything here, and then we can print it out. Okay, so now we have a variable called count that's going to keep track. We're just faking it and assuming that 2 events occurred, whatever those events are. All I'm doing now is assigning the value 2 to count to simulate something having happened. In line 8, we print out that the event occurred a certain number of times, however many. Let's run it and see what the display is. And there we see the event occurred 2 times. We had to remember that value, and that value changed. As you notice, between lines 3 and line 6, I initialized it with the value of 0, but then I changed it, simulating some event occurring, to the value of 2. That the value stored or remembered in the variable count changed as time went on. Scope. I will not discuss this topic very much. It's one of those that you can learn best by doing. I will show an example of it. Basically, what it means is variables are available for use only within a certain area, a certain visibility. Let me give you an example here. I will write a for loop for int I assigned, we'll start with value 5, while I greater than 0, I will continue, and then I'll say I gets decremented by 1 each time through the loop. The loop will just be repeated as long as that middle test, I greater than 0, is true. And I will just print I and some dots to make it a countdown. And then finally, I'll output bang. It's a countdown timer. Okay. And again, this is to show you some scope. And what I'm going to do is run it, and then I will put in a statement that fails because of scope. And then we see 5, 4, 3, 2, 1, bang. I declared a variable in line 10 called I. Well, it would look like I can say something out here after it, like line 12. I could use I. So let's try using it, plus I. The plus means concatenate, so we're going to say bang and then put the last number I saved in it. But notice the compiler has that red line under it, the red X over here. It's saying that there's a problem. I'll hover over it. It says I cannot be resolved to a variable. It means it can't see it. It cannot see that I. Now we look and we see it with our eyeballs in line 10 and say, well, there it is. What's the problem? It's not overly clear because we haven't studied for loops yet. I is defined inside this for loop, and it's visible only inside the for loop, not outside of it. This is what we call block scope. This statement in line 11, which is the statement that the for loop executes, that's the only area that I can be seen, where it's defined in line 10 and the block line 11. Outside of that, it can't be seen. In fact, the variable goes away. We can't reuse it. That's scope. It's where can a variable be seen and used.